Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to talk about the modern periodic table. Yes, after so long, that is after the contribution of Cooks, after the contribution of Daubigny and Newlands as well as Lothar Mayers, now finally, and also of the Mendeleev, and now we are going to talk about finally the modern periodic table, or we could say the long term or long form of the periodic table. So how does it had form and what are the variations that we could see in this table? Let us talk about that. So now we are going to talk about modern periodic table, but earlier we should know that according to the Mendeleev as well as according to the Lothar Mayers, the property of a chemical element, it was based on the atomic weight. But this is the new concept that we have going to learn now, that is we are going to talk about the modern periodic table, and that has a different law than that of the Mendeleev's periodic law. So what is that? Let us learn about that. So when it comes to modern periodic table, so modern periodic table states that the physical and the chemical properties of the elements are periodic functions of their atomic number. So in this case, the thing that should be highlighted is the atomic numbers. So earlier it was considered that the characteristic of an element based on its physical property or its chemical property, it was dependent on the atomic mass or atomic weight. But later it has got to know that it is dependent on the atomic numbers, and based on that only atomic number, modern periodic table has been evolved, and this is quite very much different than that of the Mendeleev's periodic table. But there are some similarities also. But because of the help of the modern periodic table, we could estimate various elements that are present in groups or that have been present in which period, even that can be estimated. But this all was because of the Mendeleev that have, or the other renowned persons that have made a classification of elements, and now we are going to see the modern periodic table, which is this. So this is a modern periodic table as we know, and it consists of basically 118 elements, in which the lower part, as you could see, that was being not discovered, but now even they are being discovered or they are being invented in that process. So making all the 118 elements to be fulfilled. So in this case, basically we could see that there are also certain elements that are not being found, but the process is going on so as to invent, also as to discover those elements. So this is the modern periodic table, which is consists of basically 118 elements, or which could occupy 118 elements, and it are being distributed in blocks, and those are basically S block, P block, this is the whole section of P block, this is the D block, and the lower part is of F block. So basically periodic table is been divided into 4 blocks or 4 groups, as we could say. 4 blocks we could say: S block, P block, D block and F block. And in this periodic table, since the Mendeleev also have made groups as well as for periods, and in this case also we could see there are total number of 18 groups, as well as there are basically 7 periods, that is the horizontal rows, as we could see. So this periodic table is known as the modern periodic table, and it consists of as you could see that there is also an arrangement in which we could see that this place is vacant, but there is a reason behind that this place is vacant and overall space is being occupied. So talking about the first period, that the first period consists of basically 2 elements, we could say, that is for hydrogen and for helium. So why there are basically 2 elements that are being present in this thing, and moreover we could see that the hydrogen is belonging to the S block. So talking about that, we know that is according to the F-Boss principle, that is the first main shell occupies the first orbit or the subshell known as S subshell. So in this, when it comes to the first period, or when I am talking about period 1, so this period 1 means it consists of the main shell as 1. So the main shell is basically 1, or I could say where n is equals to 1. And if when n is equals to 1, so I could give a orbital, and the first main shell consists of the subshell known as S subshell. So therefore we could write it as basically 1s and it could be raised to 1 or it could be raised to 2. So this s orbital can occupy basically 2 electrons, as we know. This could occupy 2 electrons, and that's the reason the first period consists of, basically you could see here, it consists of 2 elements. One is hydrogen, one is helium. Talking about the next one, for period 2, the period 2 indicates that the principal quantum number, that is n, is equals to 2, and this n is equals to 2 can be written as, it is distributed in the form of 2s2 and 2p6. So this is the maximum number of electrons that could occupy in the orbital, making 2s2 and 2p6. So in this case, what we could see that the second main shell consists of basically 8 electrons, as you could see here, that is 2 electrons of s and 6 electrons that are being occupied in p orbital. So the minimum condition there where the s could occupy the electron, it would be named as 2s1. Similarly, for the 2p, when it comes to the 2p shell, again the 2p shell can consist of 1 electron. So the maximum limit, it could reach up to total amount of 8 electrons. So that's the reason in second period you could see that there are 2 electrons that are 2 elements that are belonging to s block, while there are 6 elements that are belonging to p block. So this is for group, this is for period 2. So this was based on, we could have got to know that in period 2 there are basically a total number of 8 elements in which the 2 belongs to the s block, while the other 6 belongs to the p block. So let us talk about how the number of elements are being divided in the periodic table in group when we are talking about period 3. So in period 3, the main shell or the main quantum number that we know is basically it will have 3 shells, and 3 shells it has. So therefore it will also have 3 subshells, and those are basically 3s2, 3s, 3p and 3d. So in this case, basically the d orbital is having more energy than that of the 3p, as well as we could see that when we are considering the number of electrons that could occupy 3s and 3p, so it will make a total of 8 electrons that would occupy 3s as well as 3p on the combined form. So that's the reason in 3s also we could see that the total number of electrons are basically 8. So in this case also we have got to know that in the third period 2 belongs to s block, while the other 6 elements are belonging to the p block. And now talking about the fourth one. So in period 4, if we could observe that the main shell is basically the n will be 4, but before filling the electrons in the fourth shell, that is it will start with 4s, but before that what it happens is we are going to fill the 3d orbital first, because it is the Avos rule in which we have got to know that 3d orbital has more energy than that of the 3d have less energy than that of when we compare with the 4s. So that's the reason that the 3d will be first filled, and then the 4s and then 4p. So in this case, because when it comes to 3d it means that it will acquire basically 5 orbitals, and those 5 orbitals in which one orbital would contain 2 electrons. So that makes a total of, it can acquire maximum of 10 electrons. And after the 3d electrons, after the 3d orbitals are been filled, then it comes to basically 4s electrons, and those 4s can occupy basically those orbitals can occupy 2 electrons. And as well as we could see that after 4s is been filled, the electrons are being entered in the 4p orbitals, and those 4p orbitals can acquire a maximum of 6 electrons. So in this case also we the number of elements that in this case we could see, it is 10 plus 2 plus 6, it makes of total 18 elements that would be present in the period 4. So let us see whether it is valid or not. So in this group 4, that in the period 4, that is 1, 2, 3 and 4, this is the fourth period that we are talking about, and in this case this two are belonging to the 4s, or we could say the S block, while this are belonging to the 4p 6 that we had. That means 6 elements are belonging to the 4p, while this 3d, it is belonging to the D block, or we could say that the total number of elements in the 3D shells, the total number of electrons in the 3D orbitals is basically 10. So that makes a total of 18 elements in group in period 4. So this is how we calculate, and similarly for that we could also do for period 5 and for period 6. What happens is before filling the 4s orbital, the 3d before filling the s orbitals, the 3d orbitals will be filled, and after that even f orbitals will be filled, and so that's the making that will make this gap that we have. So this is nothing known as the lanthanoid, and thus the lanthanoid consists of basically 14 elements, because f orbitals have basically 7 orbitals. F subshell has 7 orbitals, and in which each orbital, since we know it consists of 2 electrons, so it overall makes the number of electrons to be occupied in F subshell is basically 14. So that's the reason there are basically 14 electrons in the F subshell. So therefore this are known as 4F elements, and these are known as 5F orbitals when it comes to the lower when it comes to the actinides. So that's the reason the number of groups are now, and the number of groups are now also been distributed in that manner, as well as the total number of elements that are present in the period can also be validated because of the rule that we have, and that is because of the Avbos principle as well as the Hund's rule that we have studied in atomic structure or structure of atom. So this is how they have made a statement, and because of which we could easily make a conclusion that why the first orbital, why the first period has only 2 elements, the second will have a total of 8, third will also have a total of 8, while the next one will have 18, and then it goes on. So this is basically known as the periodic table that we know. But based on this thing also, we could easily predict that suppose if we have a particular element, if we are given a particular element, and based on the atomic number, so because of that also we could easily calculate that or easily determine that to which block, to which group, as to which period is that element belonging to. So for that we have the prediction, where we could easily determine that the elements belong to which block and which period. So when it comes to the block, then how can we determine that the element is belonging to which block? It will depend on the electronic configuration, that is because of the Avbos principle. So when it comes to block, to determine that the element belongs to which block, we should always observe the outermost subshell. So while filling the electrons according to the Avbos principle, the outermost subshell that we observe, that will indicate that the element belongings will belong to that block. For example, I will give you an example, but these are the prediction that how could we determine that it belongs to which block. Talking about the period, it is easy to estimate because the period defines the principal quantum number or the main shell. So by understanding that what would be the outermost shell or what would be the outermost main shell of the particular element according to the electronic configuration, or because of the help of the Avbos principle, so in that base, on that basis we could easily determine that what will be the period of that particular element or on which period it is been located at. And talking about how can we determine for a particular group. So group is something which will be a bit where we have to do calculation. So therefore when it comes to group, so the group depends on the number of the outermost subshell, or we could say according to the FBOS principle that we write. So on that basis, if we see that the group that the element is belonging to a particular block, and in that block, suppose if it can be S block, can be P block, can be D, as well as can be F. So suppose if the element is belonging to S block, so if the element is belonging to S block, then what would be the number of group, and or which number it would be on the group 1, 2, 3 or till 18? It will depend on the number of electron in the S orbital. Number of electron present in the S orbital. For P, even that would be easily to it can be easily determined that the number of electron in P orbital plus, the rule is to know it as plus 12. And when it comes to a D block, so when it comes to D block, then the calculation would be very much easy, that is the number of electron in D orbital of that particular element when we come to know that what is the electronic configuration of that, plus 2. And this is because we know that once the S block ends, and even D block will start after that, so continuously the D block will start, and because of which we know that first S will come, then D, and then P, as we move on from left to right and we observe the periodic table. So S comes first, then D, then P, then F. But while writing the electronic configuration, we always write in S, P, D and F. So based on this thing, let me introduce that how could you determine that to which block and to which period does that belongs to. Suppose we have an element like sodium.
कंटिन्यूएशन में क्लैप करना ही सॉरी क्लैप करना ही
Continuation. Suppose if we have an element like sodium, and of whose the atomic number is calculated to be found to be 11. So how can we determine that what would be the block to which it has been belonging, what is the period that it has been located at, and what is the group to which the sodium it has been present in which of the group in periodic table. So it is very much easy to calculate. So first of all, since we know the electronic configuration, how to write it, as well as in this case the atomic weight is atomic number is also been mentioned to us. So first of all, the thing that we should do is we should do the electronic configuration of the sodium. So therefore the electronic configuration of sodium 11 can be written as, that is 1s2, 2s2, 2p6 and 3s1. So this is how, and this is how we have followed the FBOS rule also. This makes a note that the 1s has lower energy than and again after that 2s, 2p and 3s will having, this would be the orbit which will have the highest energy, and electrons are filling from the lower to the highest when it comes to the filling in orbitals. So therefore this is the one which will have the outermost subshell to be S. So since the outermost subshell is basically S, so I could easily say that this belongs to block S. So this is how can we determine that to which block it is belonging to. And talking about what would be the period to which the sodium is located at. So as we could see that the principal quantum, the highest principal quantum number in this case, or the main subshell that we could see, main shell that we could see, it is basically 3. So this is the third main shell. So therefore, and as well as the outermost shell also. So in this case, we could easily determine that the period, it would be belonging to the third period. And moreover, we could see that since it is belonging to S block, that is we are talking about in this section, since it is belonging to S block, and in this case the S block consists of 1 electron. So therefore the group that the sodium is belonging to, because as we have made a statement in this case also that if the number of electron in S block orbital is suppose 1, that would be the group number of that. So therefore, since the number of electron in this S orbital is basically 1, so therefore it means that it is belonging to the first group. So let us see whether we are right or not, or based on this thing we have calculated right or not. So this is the periodic table that we have. So we have to check the sodium in S block only. So this is the S block section where we could get the sodium. And moreover, we have found out that it will be located on the third period. So this is the first, second, and this is the third period. So here we could find sodium. And moreover, precisely we could say that it belongs to the group 1. That's the reason sodium is being calculated here. You could see. So this is how the sodium. So we could calculate, or we could determine the exact position of that element in the periodic table by using the electronic configuration, as well as by using the formulas that we have made for estimating that an element belongs to which block, which group or period. So let me give you another example. So another example that I have is titanium 22. This 22 means the atomic number of the titanium. So I could write the electronic configuration of this also. So electronic configuration of titanium can be written as basically 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, because we are fulfilling the F-Boss principle, and after 4s2 we'll fill it with 4d2. So in this case, as you could see that the total number of electrons are 22. So this 2 plus 2 plus 6, that is 10. Again 2 plus 6 plus 2, again 10, makes a total of 20, plus 2 it will make of 22. So in this case, because the we have to search first of all that to which block it has been present, in which block it is present. So as we could see that the outermost subshell or the last subshell, I could see it as D. So therefore, obviously that it would be belonging to D block. And talking about the another one, that is for what would be the period. So in this case, as I could see that the main subshell or the outermost shell in this case is basically belonging to the 4, or we could say that the principal quantum number for the outermost orbit is basically 4. So therefore, in this case, the period would be 4th. And to which group it has been belonging to? So for that, we know that when it comes to group, we have to also check the number of electrons on the d orbital. So in this case, the number of electrons on the d orbital is basically 2. So when it comes to d orbitals, so we know that the number of electrons that in this case is 2, and in this case we will add 2 because this 2 is belonging to the S block, and S block consists of 2 elements when it comes to the period. So this is how we could do. So therefore 2 plus 2, which makes basically 4th. 4. So basically it belongs to the 4th period as well as belongs to the 4th group. So let us see whether we are right or not. So titanium is the one that will get in D block. So in this case, this whole section is of D block. So this is what we have got. And moreover, we have got to know that it is belonging to the 4th period. So therefore this is 1st, 2nd, 3rd, and 4th. So in this section only we will get, and moreover in D block only we will get the titanium. And we have also got to know that it is belonging to the 4th group. So this is the first group, this is the 2nd, this is the 3rd, and this is the 4th. And yes, in the 4th group only we have got titanium. So this is how we could locate any element which is present in the periodic table based on the theory. So now let us calculate for another example if I will give. Suppose for carbon has an atomic number of 6, so we could easily calculate that by using the electronic configuration. So the electronic configuration of carbon is basically 1s2, 2s2, and 2p2. So now the first thing that we are going to do is we are going to locate that to which block it has been present. So for that we have to observe the outermost shell or outermost subshell. In this case, the outermost subshell is been found to be P. So therefore it is belonging to P block. And moreover, we could say that the period to which it has been belonging, the carbon is belonging, we have to see the outermost shell. The outermost shell is basically the 2nd shell, as you could see here. So therefore it is belonging to the 2nd period. And when it comes to group, so for group we know that we have made a formula so as to locate that how can we calculate the group of that. So in this case, we have got to know that we have to consider the number of electrons on the p orbital, plus we have to add it by 12, so as to locate that to which group does that element belongs to. So in this case, the number of electrons in the p orbital is basically 2, and purposely we'll add it with 12 so as to get 14. So basically it is belonging to 14th group. So let us check whether we are right or not by referring the periodic table. So since we are locating for carbon, so carbon is the one which will get in p block. So in this case, this is s block, this is d block, while this is p block. So in this section only we'll get carbon. And moreover, we have got to know that it belongs to the second period. So this is what the second period is. So we'll get carbon here itself, and that too in p block only. And moreover, we have got to know that it belongs to 14th group. So therefore, in this case, this is the first, second, third, fourth, fifth, sixth, seventh, and moreover, this is the 12th. This is the 13th group, and ultimately this is the 14th group. So therefore, in 14th group and in third period, we have located the carbon. So this is very much easy to do. So this is all because of the modern periodic table, as well as by using the Amboss principle and electronic configuration. It is very much easy to locate. So this is the nice thing of modern periodic table that we have discussed with you. So thank you friends for watching this video. I hope you have understood that what is the importance of periodic table, and based on that we have also did that what are the variations that we could see in this periodic table. So thank you friends for watching this video. I hope you have liked this video and you will share this video with your friends, and yes, don't forget to subscribe to Ekeeda channel. Thank you so much.